this experiment, solar cells and semiconductor diodes are studied by measuring their characteristics. Photovoltaics, i.e. electricity from solar cells, is playing an increasingly important role in energy transition towards renewables. Solar cells are series-connected, light-sensitive semiconductor diodes, mostly made of silicon, which are used to generate electricity. First, the IV characteristic of an unlit semiconductor diode is taken. Set up a circuit in which the diode mounted on the acrylic holder is connected to a voltage. Both the voltage and the current through the diode should be measured. The ammeter is connected in series, the voltmeter in parallel with the diode in the circuit. Select steps of 0.1 volts in the range from 0 to 0.4 volts and steps of 0.02 volts in the range from 0.4 to 0.8 volts. Then, the characteristic of an unlit solar cell is measured. Replace the diode with the solar module. Darken the solar cell mounted on the box with one of the optical filters and measure the IV characteristic in the range from 0 volts to about 10 volts, in steps of 1 volt. Now measure the characteristic curve of an illuminated solar cell. Use the voltage across the variable resistor as the voltage source for the solar cell. Set the output voltage of the power supply unit to its maximum and use the resistors as voltage dividers. Remove the filter and measure the characteristic curve again, from 0 to 5 volts in 1 volt steps, and for voltages above 5 volt in 0.2 volt steps. Finally, measure the characteristic of a solar cell using spectrally filtered light. Insert the various spectral filters one after another into the box. Take the characteristic curves for blue, green, and yellow light from 0 to 5 volts in 1 volt steps and for voltages above 5 volt in 0.2 volt steps. From the measurements, you can now draw the characteristic curves of the diode and solar cell in different configurations. From these, you can determine the diode threshold voltage, the short circuit current, the open circuit voltage, the maximum power point, as well as the spectral sensitivity.